Hi, this is lesson 8.1, model inverse and joint variation. The big question here is what are the differences between direct, inverse, and joint variation? So we're looking at three different ways that we can relate variables. So here's your frame. Let's look at your frame. You need to start by filling in your is about statement. So direct, inverse, and joint variation, those are our three kinds we're looking at, is about understanding different ways variables can be related. So that's what this whole frame is about, understanding the different ways we can relate variables. So let's fill in our so what statement right now. So down at the bottom here, our so what statement, what we need to make sure that you can do is you need to be able to distinguish between the forms. Okay, so you need to be able to tell the difference between the three and pick out which one we're looking at. So first, for direct variation looks like this. Y equals A times X. So to get Y, you have to multiply X by a constant. The wording that you might hear or that you might see, first of all, the variables, X and Y, vary directly. Okay, if it says the variables X and Y vary directly, we're talking about direct variation. You also might see it like this. Y varies directly with X. You can write that a little smaller so it actually fits in yours. It's kind of hard for me to write that small. So what you would need to notice about this second one here is it says Y first. So it's Y varies directly. There's my equals. And then times A, and then with X. X comes in the back here. So let's do this first example problem. It says the variables X and Y vary directly, and X equals 4 when Y equals 10. Write an equation relating X and Y. So right away, we know since they vary directly, we can write this equation, Y equals A times X. And it says Y equals 10, and X equals 4. So we're just filling those in. If we solve for A here, because we want to write an equation, so we're going to solve for A. So I have A equals 10 over 4 reduces to 5 halves. So now I found A, but the directions say write an equation relating X and Y. So we found A, we now need to go back and write our equation. So your answer would be Y equals, instead of writing A, we're going to plug 5 halves in, X. So here's your answer, Y equals 5 halves X. Number 2, it says T varies directly with U. So we've got different letters here, but we can tell the order because T varies directly. Look right here, Y varies directly. So T, we're going to put in the place of the Y. So instead of Y equals, we're going to say T equals, and we still have A, because that's our constant, and it says varies directly with U. U is what's in the place of X, so we'll write it like this. So T equals A times U. Let's look at inverse variation. Inverse variation looks like this. Y equals a constant divided by X. So for direct variation, we had X times a constant. For inverse variation, you have a constant divided by X. So the wording that you might see here, first of all, the variables, X and Y, vary inversely. Okay, the variables X and Y vary inversely. That's one thing you might see. You might also see Y varies inversely I gotta spell that right, inversely with x. So you might see it written either of those two ways. So number 3 here, it says the variables x and y vary inversely. So we know we're using this form. Y equals 3 when x equals 6. So we know we're going to plug those in. The question says write an equation relating x and y. So our final answer should look like this, but we've got to plug our a in here. So let's actually do the work. Instead of y, I'm going to put 3 equals a divided by, instead of x, I'm going to put 6. And then to solve this, I'll multiply both sides by 6. That'll allow me to get a alone. So a equals 6 times 3 is 18. So I found a, but the directions say to write an equation. So now we need to go back and plug a in. So 18 in for a. So our equation is y equals 18 divided by x. And there's your answer. Number 4 here, x varies inversely with the cube of y. So the cube of y, that's y to the third. And then it says x varies inversely. So x is what they put in place of the y here. So they're throwing us off a little bit. So instead of y equals, I'm going to put x equals. It says it varies inversely with the cube of y. So I need to keep this a the same over, and I need the cube of y down here. So this is y to the third. That would be the cube of y. So x equals a divided by y to the third. This is why you have to look at your wording and make sure you get your variables in the right spot. The third form that we're going to look at is joint variation, and joint variation looks like this. Z equals a, so there's my constant, times x times y. So if you notice, now we've got 3 unknowns here. We've got 3 variables, then we still have our constant a. So the wording that you might see, first of all, you might see the variables. X, y, and z vary jointly. Okay, that's one thing you might see. The variables x, y, and z vary jointly. You might also see z varies jointly. With x and y. Okay, so those are the 2 ways that you might see this written. So number 5 here, it says z varies jointly with x and y. So notice that's this form right here. So we know we're going to use our formula right away as soon as we see that z varies jointly. So I know I'm going to use the formula z equals a times xy. If z equals negative 84, so we're going to plug negative 84 right in for z. When x equals negative 4 and y equals 3, so I keep a here, times negative 4 times 3. Write an equation relating x, y, and z. So again, we've got to solve for a here so that we can write our equation. And to get a alone, I'm going to have to divide both sides by what's next to a. Negative 4 times 3 is negative 12, so I'll divide them both by negative 12. So a equals 7. So my equation, I'm going to keep my z here. Instead of a, I'm going to plug what I found. I found 7. So z equals 7 times x times y. And there's my answer. I found my a value, and then I wrote my equation. Number 6, k varies jointly with x and y, and inversely with m. Write a general equation relating the variables. So let's look first here. K varies jointly, so we know we're using our joint variation here, with x and y. So let's write just for that. K equals a times x times y. Okay, but it's got more to this problem. It says, and inversely with m. So your inverse variation, let's think about that. If you look back at your frame, at the top column, inverse is y equals a divided by x. Okay, so in inversely with m would tell us we need to do some division here, and we need to divide by m. So this would be your answer for k varies jointly with x and y and inversely with m. Let's look at the other side of your frame. Okay, so here's the other side of our frame. Okay. This is still about the different types or the different ways we can relate variables. So this is about different ways variables are related. Okay. So we got two main ideas. We're going to do a few examples where we pick out what type of variation it is. And then we're also going to do some looking at tables. Okay, so let's look. My example 1 is not on your page, so I'm going to write it right here. Example 1 is x, y equals 5. Okay, so we want to find what type of variation it is and how do I tell. So we've got these three types. I'm going to write them over here on the side. We've got y equals a times x. That's direct. We've also got inverse. And that's y equals a divided by x. So notice those two are both solved for y, so that should be a clue. And then we've got joint, and that's z equals axy. And for this one, we've got three variables. So we can rule out joint right away because we don't have three variables. We only got two variables. So we're looking between inverse and direct. Both of these are solved for y, so let's solve for y to see what we get. So if I solve example 1 for y, we've got xy equals 5, divide both sides by x. So I have y equals 5 divided by x. And comparing here, this looks like this problem. So our type here is inverse. Example 2, we're going to do p divided by q equals 92. Okay, so let's look. We've got only two variables. We've got two variables, so we can rule out joint right away. Cross out joint, that one doesn't work. So we're going to do one of these two things. And we're going to actually solve this for p, because p comes first in the alphabet. So let's solve it for p. P divided by q equals 92. So if I multiply both sides by q, I have p equals 92q. And let's compare. Does it look like inverse or direct? Well, we got a times x, so we got a constant times a variable. Here I've got a constant times a variable, so it's definitely direct. So the type is direct. And then my last one, y equals 2 times x plus 4. Okay, now let's look here. 2 times the quantity x plus 4. There is no addition in any of these. There's no addition and no subtracting. Even if I distribute it here, I would still have addition. So because there's no addition or subtracting in any of these, it's not possible for it to be either of them. So the type is neither. Okay. Now let's look at the other. Using data to determine direct or inverse variation. So a couple of hints. If you're looking at a table to see if it's direct, y divided by x must be constant. So if you do y divided by x for all of the ordered pairs, that should be constant if it's direct. To see if it's inverse, xy must be constant. Okay, so to see if it's an inverse relationship, x, y, when you multiply them, you have to get a constant number. So let's look at example 1 here. If I do 45 divided by 5, I get 9. If I do 15 divided by 15, I get 1. So 9 and 1, are those equal? No. So it's not equal when I divide. What about if I multiply this? Okay, 45 times 5, well, that's 225. And if I do 22.5 times 10, that's 225. And if you did 15 times 15, that's 225. 11.25 times 20 is 225. 9 times 25 is 225. So if we do m times n, that equals 225. So what type of is it? Well, we said if you multiply them and it's constant, it's inverse variation. So the type is inverse. And that number that we got, that constant number, that's actually our a value, our constant. So it would be y equals 225 divided by x, but those aren't the variables that we have here. Normally we would say x, y, just like this. So we're going to put m in the place of x and n in the place of y. So, or n equals 225 divided by m. So when m equals 45, what does n equal? Well, n's going to equal 225 divided by 45, which is 5. Well, let's look at the next example here. I'll do it in a different color just so it stands out a little more. So let's try dividing here. So let's see if they're equal when I divide. So if I do 16 divided by 4, that's 4. 11 divided by 5, is that 4? No. So it's not equal when you divide. Let's try our multiplying. If you multiply, I'm going to pick a couple easy ones here. 11 times 5, that's 55. 6 times 11, that's 66. 55 and 66 are not equal to each other. So it's not equal when you multiply. Okay, so our answer is neither. So we can't write an equation and we can't say that. This is the end of this lesson. Make sure if you had any questions at all, you starred them so that we can go through them in class tomorrow. I would just take the time to double check everything, make sure you got everything filled in. Have a great night.